NEC engines, slow down and shut down, alarms and trips. We'll talk about today alarms and trips. All right. Main engine is ME engine, Camshaft Labs engine. We have been talking about. So there will be, of course, some condition which need to be met before the engine is started, and some special running condition, and how they are influenced by various factors that we will see. Now, starting function, of course, shall be blocked by the engine control system if certain condition exists. Which are those conditions? These are basically interlocks. Shutdown. We'll see what condition causes the shutdown. Condition which may cause the shutdown, if that exists, of course, engine cannot be started. If a condition causing the shutdown exists, engine cannot be started. Main starting valve blocked. Of course, very clear. If the main starting bar is blocked, how the engine will be started? Because they will not, no air will come to the required cylinder. Obviously, the engine cannot be started. Therefore, there will be a start block. Control air is vented for whatever reason. If we had seen the control air is required, we have seen the diagram. Control air is required to open the main or open the slow turn valve. So that is required. The control unless control air is there, those valve cannot be opened. So that relevant MOP screen will just show you from the engine navigation bar. You can see in module 4 also. Turning gear engage. Turning gear engage, that means engine cannot be started. This also every marine engineer knows. Start block shall also be initiated by the engine ECS, engine control system, if engine control is with the bridge, but auxiliary blowers are not running operational, or not on auto mode. By mistake, it was kept on manual for whatever reason. Start block in ME engine shall also be initiated by engine control system if the engine control is on the bridge, but starting air pressure is below, let's say less than 12 kg. All right. This is your diagram we are talking about. You need control air. You need control air. Then only the slow turn valve will activated and control area will go and open the slow turn valve. Otherwise, slow turn valve cannot be opened. Similarly, main valve cannot be opened. If one or more of the above condition exists, start block alarm will be raised. This is slow turn valve. The main starting valve, if it's not in the running condition, in service condition, they will be blocked. It will be red or orange. Start the distributor system in service. That means the control air available. Starting air pressure below 12, no bridge control. Control air pressure, no control air pressure, start block. Turning engage, start block. Auxiliary blower not running, bridge control, start block. Hydraulic power supply not running or low pressure, hydraulic pressure low, no bridge control. All right. No hydraulic pressure in the even from the local stand or LOP or MOP or in the engine control room, you cannot start the engine. Hydraulic pressure is required. So start failure is raised under the following condition. Let's say three attempts were made to start the engine, but engine did not start for whatever reason. There can be a number of reasons. Slow turning failed or timed out. Slow turn when we affect actually engine turns on 8 RPM. Roughly, that means roughly 7-8 seconds it takes to complete one turn. At least one turn must be completed. All right. Before engine, before air will go and start the engine, main air. If any of the following condition has been met, start failure alarm will sound. Slow turning mode cannot be cancelled. Slow turning mode can be actually cancelled by what is called increased limitation. There's certain screen you will find when in operation, MOP screen, operation screen, increase limitation. Let's say engine has been stopped for a while and the bridge gives a movement. So engine first will turn one turn at least. But because it's taking time, 7 to 8 seconds will take 8 RPM per minute, and bridge is again phone come, oh, why no pilot is crying? Pilot is saying, no, I know just no start. You can increase the limitation. So it will cut off. That means cancel will be. So during maneuvering, slow turning will take place if engine has been stopped for 30 minutes. If engine has been stopped for a long time, slow turning will take place first, and then engine main air will go through the main starting valve and engine will start and the fuel will be released. So this time has been increased on some ship by to 30, 60 minutes because pilots and bridge team sometimes complain. So you see what is your system on your ship. So this is done as per the request received from the bridge. Sometimes pilot complain. Blower control. Auxiliary blower is to be on auto mode. Manual operation of the auxiliary blower is mainly intended for use during fault finding and test situation. So normally do not keep auxiliary blowers on manual mode. You always keep on auto mode. You can keep it on manual mode, but selecting manual mode will always raise an alarm in the MOP. So if you know you have put it on manual and alarm has come, accept it. So also check screen scavenge air on auxiliary navigation bar in module 4. You will find that I have explained when auxiliary blowers are put on manual mode, alarm will come. Auxiliary blowers will of course automatically stop after the engine stops during maneuvering for a certain period of time, usually 15 minutes. It takes about 40 seconds to start the auxiliary blowers, all three, because they will start sequentially, one by one. This also sometimes bridge complaints or pilot complaints. Auxiliary blowers will automatically start when a telegraph command is given. So if engine has been stopped for a while and the bridge gives a telegraph command on the when the control is with the wheelhouse, a start of the engine will be delayed till the time all the blowers have started. All right. In case there are 2 or 3 blowers, all the blowers which are there in the system must come on. Then only uh, fuel will go. Then only engine will start. Certain ships have increased the time to stop the blower from 15 to 30 minutes, as I was telling, during maneuvering on complaints from the pilots. Note, auxiliary blowers can be started manually also if a request is made by the bridge about delay in starting the engine. That can be done. So, but you have to put it on manual mode. So alarm will come. On the MOP screen, indication will be there about the status of the auxiliary blowers. When the blowers are stopped during maneuvering, of course, delayed start. When the blowers are starting, indication will come preparing start. When the blowers are running, prepare for start. That is the main engine is prepared, ready for start. Speed avoidance. This in the algorithm. Critical speed automatic avoidance is included in the engine control system algorithm for the ship. Stopping the engine. Stopping function is included in the ECS engine control system. Stopping signal goes to ECU, then an ECU then directs to the CCU as per the position of the telegraph lever while maneuvering. If a condition exists which requires shutdown, then remote control system and safety system will give a signal to EICU, engine interface control unit, which in turn will communicate with ECU and in turn CCU. CCU will then stop injection through the fever valve. Similarly, stopping the engine, ECS stopping signal will go to ECU and then ECU to CCU, and then all CCU will stop injection through the fever valve. Remember, stopping the engine, conventional engine is through puncture valve. There is no puncture valve here. So here CCU will stop injection through the fever valve. Just something like this, your Steve limiter 0, for example, something like that. Reversing function is in the engine control system. Telegraph command through ECU, EICU if on a bridge, and control room control or through ECU if local control, LOP, goes to the CCU, and required unit gets the starting air as the pilot air gets into the starting air wall of the cylinder, which would turn the engine in the desired direction. So here, since there is no distributor, ECU will direct and then CCU to CCU, which will admit the pilot air to that starting air wall, which is in a position to turn the engine, let's say, in stern direction. If the movement was instant, that is reversing. Of last time it was in stern direction, now it will decide which unit to go air so that the engine will turn in the head direction. All right. So these are already set up in the algorithm. Of course, limiters are set up, of course. When the engine start, amount of fuel will be controlled. Start air, start limiter. Of course, and scrunch air limiter. However, during crash stunt, limiters are cancelled. All right. Module 5, Module 5, Video 2. Video 2. EICU failure. There is a possibility the EICU has failed. If EICU failed, in case both the EICU fail, one fails doesn't matter because other is taking 100% functioning. In case both the EICU failure occur, engine is kept in the condition in which it was prior to the failure of the EICU. But engine RPM cannot be controlled. Change not in the control room also, it cannot be controlled. Change to LOP and the engine can be controlled from the LOP only. If EICU fail for whatever reason, both the EICU has failed, neither from the bridge nor from the engine control room, you can control the engine. Okay. Shutdown and slowdown. They are cancelable shutdown and slowdown and or non-cancelable shutdown and slowdown. So we'll see what are the slowdown or shutdown. Non-cancelable shutdown. Hydraulic pump lube oil inlet oil pressure drops to set pressure. Some minimum set pressure. Okay. Inlet pressure. Normally set at 0.5 bar. Then a shutdown shall occur. Because no suction oil. No oil is coming to the suction. That means sensors are fitted, pressure transmitter. So engine will stop because no lube oil available to the hydraulic pump. This shutdown cannot be cancelled. Naturally, this is non-cancelable. No hydraulic oil, how to run the engine? Engine cannot run. So naturally, shutdown will occur. And inlet pressure has to be restored above this value. Make sure your supply main lube oil pump is running and supplying the pressure. Filter is not choked and all. Then only this alarm, this shutdown will go away. Hydraulic pump lube oil, low pressure is normal, but pressure transmitter has failed. For some reason, hydraulic pump lube oil pressure is normal, but the pressure transmitter has failed because actually it is a pressure transmitter which tells the system what is the actually pressure. The actual pressure may be there, manual gauge might be showing, but the pressure transmitter is giving you a faulty signal. So actually, one pressure transmitter failure will not initiate a shutdown. Majority of the pressure transmitter when failed, then only shutdown will occur. All right. Invalidation is also possible, but you should have time for that. Hydraulic oil discharge side high pressure falls below default set pressure. But the discharge set pressure is set, whatever, is set below the default pressure. In your ship, it might be different. Maybe normally it's 150 to 175 or 180 bar. A shutdown shall occur which cannot be cancelled unless hydraulic oil pressure is brought above the default value. So now, in this case, if maneuvering, what you do? You reduce RPM. Tell the bridge to go into dead slow or slow ahead only to avoid any mishap. That's all. Because every hydraulic pressure has certain amount of fuel which can be released. The pressure is reduced, so amount of fuel cannot be reduced, cannot be supplied more than that. If you are running at higher RPM, more hydraulic pressure is required. So reduce RPM. That may give you time to find out what is the fault, and if possible, increase, get the pressure back to the system. Thrust block temperature very high, but these are non-cancelable shutdown. Non-cancelable. High, note down the default setting. Normally it's 90 degree. Thrust block temperature high, there will be shutdown. Non-cancelable shutdown. All right. There are shutdown which can be cancelled. Naturally means override now. Large hydrogen large hydraulic oil leakage in the double walled pipe. Default setting is 45 liters per minute. Check on your vessel and keep a note. Hydraulic oil leakage take place in your double walled pipe. There will be a cancelable shutdown. First alarm will come, of course. Leakage alarm from hydraulic unit persists for more than 60 minutes. Then cancelable shutdown will come. Large is amount is 40 liters per minute, 45 liters per minute and above. But this is cancelable because if you are maneuvering, you don't want engine to stop. Leakage is there, too much leakage is there, but you can live with it because running the engine during maneuvering is more important. You can deal with it later after the engine has stopped, if ship has been berthed. Vessel fitted with shaft generator. On engine shutdown shall occur if shaft generator is not disconnected from the bus bar within a set time after slowdown. Of course, this also can be checked what is the default sorting on your ship. Low jacket cooling water pressure. Normally it is 0.1 bar. The discharge cooling water pressure is low. The engine must shut down, but cancelable. Again, during maneuvering, you can live with it for some time. Slow down. Main engine cylinder lubrication failure. A slowdown shall occur. There are two scenarios when a slowdown shall occur. Cylinder lubricator. Lubricator feedback sensor has failed. That's why actually lubrication is taking place. Cylinder lubrication is going on, but sensor has failed. Or second is no cylinder oil supply for whatever reason. Number two, no exhaust valve movement. Also slow down. Feedback sensor is giving you information that no, because feedback sensor, what is the purpose of feedback sensor? Give you the stroke of the exhaust valve. So it's telling you it's not moving. So no movement of the exhaust valve. Shut down, slow down. All miss detector high miss alarm. Of course, slow down. Lubal temperature in that inlet of the engine is high. Of course, slow down. So you have to remove the condition, and then only slow down can be removed. Cooling temperature high, more than 75. Inlet. This is inlet temperature. Jacket water inlet temperature high, more than 95. Oh, sorry, this piston cooling temperature is high, 75 degree. Jacket water inlet temperature high, 95 degree. Engine cylinder exhaust temperature is high, more than 450 degrees centigrade. Slow down. Scavenge air temperature is high. Slow down. More than 65 degrees centigrade. Thrust block temperature is high, more than 75. 90 was shut down. This is slow down. Control air pressure is low, less than 5.51, slow down. Exhaust gas temperature, high deviation between two units, 3 units, among that is between the units. Slow down. All right.